Hello friends, welcome to Live Tech Study. I am Pranav. This is the recording of one of my sessions that I have taken with one of the students. If you are also looking for similar kind of sessions, you can contact me on livetechstudy@gmail.com. Thank you. So today we will start with a new topic which is related to multi-threading. We will understand what is multi-threading and in what kind of scenarios we should use that and what are the benefits of using multi-threading. So let me show you a simple example and then we will go ahead with multi-threading. So in general what happens is, let's say we have written few lines of code in our main method. Like line number 1, 2, 3, 4. There are some statement written in every line. So what happens? First line number 1 is executed, then line number 2 is executed, line number 3 and then line number 4. If we want to execute these two lines concurrently, in those kinds of scenarios we think about multi-threading. Why would we want to execute things in concurrently? Let's take a real life example, like uh, let's think about a web server, like websites. At a single point of time, many users are trying to access this website, right?
Yeah.
But if we saw that the code is executed one by one. So what would happen if there is no concept of multi-threading? Then what would happen? User one would come, the all the requests, all the code which is required to serve this request will be executed and then response would be sent to user one. But if both of the user, let's say, come at 9 a.m., then what would happen? User one's request will be served. Only after that the processing of user 2 will start, because we see that the lines are executed one by one. There is no way to serve the two requests concurrently if there is no concept of multi-threading. Okay, so there are scenarios in which we would want to execute many codes concurrently. What we would want? We want to execute the codes which is required for serving request 1. At the same time, we will also want to uh, run the code which is required to serve the request of user 2, right?
Okay.
But in general what happens if if there are 4 sysout lines, uh, they will be executed one by one. Like there is let me open an example and I will show that. So let's say I have this simple class and I have written some code. Let's say I have written like 4 lines. So what would happen? First line number 6 will be executed, then line number 7, then 8 and then 9. In this way the code execution happens. So what happens when we run this application? A process is launched. That process is the JVM process. When we run this code, a process is launched. A JVM process is launched. In that JVM process, by default, one thread is created. By default, one thread is created. What is a thread? Thread is a lightweight process. Lightweight process. What that means is, for creating a process, we need some resource from the OS. We will need some memory. We will need some RAM to execute this process. So all those resources will be taken from the operating system to launch a process. Inside a process, there can be more than one thread. These threads will share the resource that this process has been provided. That is why all these threads are called lightweight process. That means many of the resources that is given to the process by the operating system will be shared by all these threads that we will create in that process. All these threads will be sharing the resources provided by the operating system to that process. So by default, when we launch our Java application, one thread is created. That thread is called main thread. This main thread is created by default, and all the code that we have written in our Java application will be executed in that thread. So now comes that how the resources are utilized by this thread. So like whenever you write some line of code, whenever we write some line of code, to execute that, CPU is required. To execute one line, some CPU resource will be required. So what happens when we let's say if we talk about the architecture of CPU has many cores. Modern CPU has many cores. So let's say if there are two cores, then two thread can run concurrently. If there is only one core in the CPU, then only one thread can execute in the CPU. So let's say our CPU has only one core and we have started two threads. In that scenario, what will happen? First, the code required by thread 1 will execute. Only after that, the code of thread 2 can run. If we have more than one core, let's say two cores, then all these two threads can run concurrently. At the same time, these codes can run. If I had said thread 1 to print 1 and thread 2 to print 2, then they will be executed at the same point of time. They can execute same point of time. But if I have only one core, then only one thread can run. To understand this better, let's say like if I have one employee, then that employee can work on one task at a point of time only. So he can execute only one instruction at a time. If I provide him two works, he will have to, like, he will first complete work 1, then he will start work 2. In the similar way, if I had two employees, they can pick one of the work and start working on them concurrently. The similarity is with the cores. If I have two cores, two thread can run concurrently. Otherwise, if I have only one core, first thread 1 will complete and then thread 2 will complete, right? So now let's see how we can create threads in Java. By default, when we run this code, a thread is by default created, and that is called main thread. we will see how we can create new threads and how we can use those threads. So there are actually two ways to create threads in Java. One is by extending thread class, and other is by implementing runnable interface. We will see both these examples. So in real life, multi-threading will be used heavily, because we would want to serve more than one customer at single point of time. If you want to serve more than one customer at a single point of time, then you need to have more than one thread. Only then you can run code concurrently for different requests. So this concept is heavily used in any real time project. Now, okay, so let's say that currently if I run, first 1 is printed, then 2, 3 and 4. What I want is that I want to start a new thread, and I want to run these 2 lines of code in that thread. What I want, these first line 1 and 2 is printed in main thread, and these 2 lines are printed in the other thread that I will start. I am going to show you how we can do that. So what happens is, what you can do is you have to create a class. Let's call it, I am showing you the first way by extending the thread class. Then we will talk about runnable as well. So when I say by extending thread class, let me show you the thread class. There is a thread class by default in Java. There is this class thread. If you want to create a new thread, you can extend this thread class, and you can write whatever code you want in the run method. This class has a run method. We will override this run method, and we will write whatever code we want to run in our new thread. In current scenario, we wanted to run these 2 lines of code in my new thread, so I will write that code in the run method. So let's write that example and things will become more clear. I will create a new class, my thread. This is going to extend the thread class, and I am going to override the run method that was present in that class. And what we wanted is, we wanted to run these 2 lines of code in this thread. So I will write that in the run method. Whatever code you want to execute in new thread, you want this, write that in this run method. Now what I will do, I will create a new thread t1 equal to new my thread, and what we will do, we will call t1.start. When we call this t1.start, what is that? It starts a new thread, and it runs whatever code we have written in the run method. Okay, so to show you which lines of code is executed in which thread, I am going to print the thread name as well. What I will do, I will thread dot current thread dot get name. This method is used to print the name of the thread. In all the code, I am going to write this part, and it will show which thread executed which line, and things will become more clear. Okay, so what code I have written in this scenario? Whenever we run this code, by default a thread is created, and these two lines will be run in that thread. The default thread that is created is called main thread. Now what, after that what I have done, I have created a new thread, and then I have started that thread. So then this will start a new thread and run that code. Now let me write one more line to so make it more perfect. Okay, so now uh, let's think what will happen if we were not like aware of about thread. What will we think? That first line number 6 will be executed, then line number 7 will be executed, then line 8, then line 9. So line 9 goes to this run method, then it will execute 18 and 19, and then line number 10 will be executed, because code is executed sequentially. But whenever you start a new thread, then the two thread will run concurrently. That means that this line and this line is running in main thread, and this line is running in our new thread. They are actually executing at the same point of time. Let me run this code. So do you see uh, does this make sense, or like what you were actually expecting in the output and what I have tried to explain? If you see it
So
is, yeah,
but I didn't see the line number 18 and 19
yeah,
any difference when it comes to printer. I was thinking about, now I understand that in main is a thread
mm-hmm.
and it executed 1 and 2 and 5.
Mm-hmm.
So the other two you say it will print concurrently.
Yeah,
In the background it prints concurrently. So
yeah, yeah.
you get it simultaneous together. So what will happen if we? I mean, I was just trying to see the debug mode, how it happens. Like for example, if I'm running, I will be running number 6, line 6, line 7.
Mm-hmm.
Then I'm going, calling 9, the 9. I understand that it goes to run, but
it will create a new thread. New thread means whatever I have written in that thread will be executed at the same point of time. So like the calculation is happening at the same time. These lines are executing at the same time as this line. So like line number 10 is not waiting for the completion of line number 18 and 19.
Oh, okay.
If like,
so you
yeah.
say 9, so you say 10, line 10 and line 18, 19, they are not really waiting each other.
Yes, yeah. They are working on their code at the same point of time. Earlier what used to happen in one thread, like if you see first line number 6 will be executed, then 7. It will never happen that line number 7 will be executed first and then 6, because they are running sequentially. But in this current, in case of multi-threading, the code is executing at the same point of time. Let me like write few more lines, then I am going to write few more lines. It will make more sense. Now if I run this code, what do you expect? What it will print in terms of integers? 1, 2, then
it will be 5, 6, 7, 8, then 3, 4.
why do you say so? Because
because you say that when it gets to the thread, it creates the objective thread, and then it calls.
Yeah.
As soon as it calls, it will continue doing line 19, actually line 21 and 22, while they still executing line 10, 11, 12, and 13. So whichever get called first will go first. So which means it will go through 1, 2, 5, 6, 7, 8, and 3, 4.
Okay, let me run this and then I will explain why that is not correct. If I run this, do you see? Okay, it printed in the same order as you said. Let me run it again.
Okay.
And okay, every time it is printing in the. Let me write some more code. Then I will be able to make sense. Let me write 9, 10, 11, 12. Now do you see something different?
Yeah.
You were expecting 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, then 3, 4, right?
Yeah.
So now you see something different.
So why was there the 9th threshold?
No, actually, after line number 9, 2 threads are running concurrently. So you cannot predict which will run, which will print first, because two employees are working concurrently. Out of them, like we have 2 employees and I have said them to print something. So out of them, any of them could print first, right? Because both are working at the same point of time. So like after 1, 2, 2 workers are there. One is printing 5, 6, 7, 8, 9, 10 and other is printing 3, 4. So like first thread printed 5, 6 and in between the other employee completed printing 3.
Yeah, but what I didn't understand is that if you had 5, 6, 7, and 8, as you can see up to the 9, it prints main. Right?
Yeah.
Like if you have to 1 up to 10, then it will print 3 and 4.
Yeah.
The thread.
Yeah.
But when you added the 11 and the 12, now it is start printing 3, then main, then so it is a 10 the threshold.
No, thread 10 is not threshold. So what actually happened when line number 6 was executed, actually a new thread, main thread was created and that thread started to run the code. When we came to line number 9, we said to the JVM, start new thread. A starting new thread will take some time, like 1 millisecond. In between, my main thread continued working. Okay, as soon as new thread started, he also started to work.
Oh, okay. When it says start the new thread, while it processes to start a new thread, the codes continue working. When the new thread starts, it automatically sends it at the same time.
Yeah.
Okay. So, all right, I get it.
Yeah. So like in this scenario, you cannot predict what will be output. You can only say that 1, 2 will be printed every time in the sequence. After that, you cannot say which will be printed first, whether 5, 4, 6, 7, 8, 9 or 3, 4, because they both are working at the same time. Like if I run many times, you will see a different output. If you see now the output is different.
Yeah, it's unpredicted.
Yeah, it's unpredicted.
Because you say it depends on CPU.
Yeah.
The memory.
Yeah.
Okay.
Currently, Yeah,
I
yeah,
get it.
yeah. So like how many threads can run at the same point of time depends on the number of cores that you have in your CPU. I have currently 8 core system, so I can run 8 threads at a single point of time. So like
Okay.
in reality, uh, 8 threads will be working at the same point of time. If I create more than 8 threads, then like there is a concept of thread scheduling. uh, Let me describe that as well. So like let's say if I have 8 core machine, okay, I if I have started, let's say, 8 threads, then each of the thread will get one core and they will run. Let's say if I have started, let's say, 16 threads, then what will happen? There is concept of thread scheduling. What it does is like like what it will do, it will try to schedule the all the threads, all the 16 thread. So like what it will do, it will give like CPU for 1 second to thread 1, then it will give take the CPU from thread 1, it will give it to thread 2. In this way it will provide the CPU to all the threads that I have created.
Oh, okay.
Yeah, but like it gives some time slash to execute thread T1. After that it will take CPU from thread 1 and it will give CPU to thread 2. uh, in this way all the threads will be able to progress. So like uh, let's say if I had only one core, if I had only one core in my system. So core is what? You have a CPU, and in that CPU you can have many cores. In my system I have 8 cores. Let's say if my system had only one core, if my system had only one core, and I had created two threads, thread T1 and thread T2, what would happen? That thread scheduler will give time one, let's say, 1 second to execute thread T1, then it will give the time 1 second to thread 2, then it will again give 1 second time to thread 2. In this way, what thread scheduler does is it gives some time to each thread to execute itself. If I had 8 cores, 8 8 threads can run at a single point of time. So if I have let's say 8 threads, each will be executing at the same point of time. If I have more than 8 thread, then again that concept will come, that first thread will take some CPU, some time, and then scheduler will give time to other thread also to execute. Okay.
All right. Got
Yeah.
it.
Okay. So now we have seen this, how we can create a new thread and how we can start that thread. So we were talking about the web server, how like when more than one user is trying to access the web server, then how that is handled actually is like let's say I have hosted my website on my web server. Okay, so more than one user is trying to access my website. So what web server does is, in the background, it creates, like user 1 comes, web server will create thread 1, and thread 1 will be running the code which is required to serve user 1. User 2 comes, web server will create thread 2 and it will be serving the user 2. In this way there are more than one thread on the web server to actually process the request coming from the users. That is why at the same time more than one thread, one user is able to access our website. this doesn't mean that if like 1000 user are accessing my website, 1000 thread will be created. This doesn't mean that. Actually, there is a fixed number of threads defined in the web server, let's say 16. So 16 threads will be created, and they will be processing the request coming from the users. But let's say at the same time 10,000 requests come to the web server, then what will happen? Then like again that concept of the time slicing will come into the picture. Like let's say that for serving the request of the user one, we need to access the database. So when that thread is accessing the database, the CPU will be free, so that thread can process the other request as well. When we are reading the data from the database or let's say file system, at that point of time CPU is not required to do that. Like for reading those things, CPU is not required. These are called IO operation. For IO operation you do not need CPU. So at that point of time CPU will be free, so other thread can use that CPU. So in this way all those processing happens. Okay, so we saw that how we can create a thread and how we can like execute something in that thread. Here we wanted to execute these two lines in the new thread, so we created a thread class, a class which is extending thread, and that we wrote those lines in that thread. I have said that there is another way to create threads as well. So that is using the implementing the runnable interface. Now I will show you that example. So what I will have to do, I will have to like extend the runnable interface. Runnable is interface. Let me call it my runnable implements runnable, and runnable interface has a method run. Again we will have to implement that. Now all the concepts of overriding interface are coming into the picture. Now we have this runnable interface, and whatever I want to execute, I can execute that over there. So let me write like something like this. Let's say I want to print this 13, 14. First let me comment this part, and then we will again uncomment this part. What I have done is like now if I wanted to create the thread using the other method, what I will have to do, let's call it thread t2 equal to new thread, and thread takes a runnable also as an argument. What I can do is I pass my runnable, and then again once I have this t2 I can start this. So in this way also I have created a new thread. What I have done this.
So let me ask a question.
Yeah.
In line number 8,
yeah,
we put the inside the premises for your thread.
Yeah.
Is you can you do that? Like, can you say that t2 dot my runnable? Like if you have new line, for example, now let's say if you don't have anything inside premise parentheses, what will happen? Like that, yeah.
Okay, so
can you open new line, click enter, click enter,
yeah,
and then write t2
dot
runnable. What was that?
No. We do not have like set. You wanted to set that runnable, right?
No, I thought we can. Oh, you were calling a class, right?
Yes. So like this, the constructor of this thread class, either this constructor can take a runnable object. So what we could have written is like my runnable are equal to new my runnable, and I could have passed that r over here. Is this what you wanted to write?
Okay, so because this is now is the object you pass in.
Yeah.
So instead doing this, the line number 8.
Yeah.
Basically, you open a parenthesis,
Yeah.
you say new runnable,
Yeah.
you pass that class as
Yeah.
object.
Yeah.
Okay, got it.
Okay.
Is this the one you have right now and the one you had before? They both okay.
They are same.
Your goal is to pass thread. Okay, so let me ask you.
No.
Why do you pass in the thread again here?
Okay.
Why don't you just extend it?
Yeah. Okay. So your question is very correct. Why there are two ways to create threads, right? That's the question. Yeah. So like we can extend only one class in Java. Like let's say this my thread wanted to extend any other class as well. In those kind of scenarios, we should use this other approach, line number 34. Like what we want is my thread class can extend other classes as well, but if I extend thread, then I cannot extend other classes because we can extend only one class. Do I make myself clear?
I understand. One class can extend it only one time and one class, but can implement it multiple times. But right now, let's just think about it.
Yeah.
In line 26,
yeah,
you extended the thread.
Yeah.
The same thing happened line 34.
No.
You have
No.
another class.
Yeah. It is.
Right? You have another class.
Yeah.
So this class you implemented
runnable. Yeah.
But can you also extend it the thread? That's my question.
But
line 34.
Yeah.
Can you extend line 34?
Yeah. You want to write this thing?
Yeah. Will that work then?
It will work, but it will work, but like it has no significance.
Okay.
Yeah. Because like okay, why we actually wanted to go via this route? Why Java people had two ways to do this? Actually, what is like let's say Java has not provided this way. What Java had said that we always have to extend thread class to like create new threads. In that scenario, what will happen? Let's say my thread was extending the student class, let's say. Okay. Now I want to make my thread, my thread a thread also. So to create a thread, what we'll have to do? Okay.
No, actually, I was not trying to say that. I think you misunderstood from me.
Yeah.
What I was trying to say is that if you calling a run method, okay, within these two classes, okay.
Yeah.
If you look at the method are the same, okay,
yeah,
right?
Yeah.
They both run. One you extended thread, the other one you implemented runnable.
Yeah.
So first foremost question is, what is the difference between the thread and runnable?
Thread is a class, runnable is an interface.
Yeah. Okay. So I understand. So what? So are you saying that the interface has a runnable also?
Yes. Run method. Yeah, run method.
But I'm looking right now. Okay. And so you call this interface. Okay?
Yeah. I am implementing that interface.
What is the disadvantage using the runnable versus thread in line 34? In line 34, what is the disadvantage if we use a thread rather than interface?
The disadvantage is that if I extend thread, okay, let me extends,
because the reason is that you have an implementation interface, which I understand, but I don't get it, the advantage.
Okay, let's say this is my current structure. Now I want to create my runnable as a thread also. In that scenario, what we will have to do, we will have to extend the thread also, right? This is my current structure. Now what I want is, I want to create this class, my runnable, a thread also. So do that, what will you have to do? We will have to extend thread, right? But we cannot extend more than one class.
Yeah, I understand, but you are not in here, line 84. You just put the accepted handle and you don't want it that way. Let's say, get rid of that.
No, I want this. I want this, and still I want to make my runnable a thread. How will you implement that?
So if you want, then the interface comes in.
Yes, that's the advantage of interface.
So you say that, okay, if we want to later on it, extending some another function, then you see that when we, like for example, accept the handling, which is another class, right? It's interface now. And now the only way to have the runnable method is to use the implementation. Correct.
That's the advantage of interface.
But here you are not extending any other class. The only, in line 34, only thing you had was that my runnable implementation runnable.
So
I mean, you were not extending any other.
But if we want to extend, then in those scenarios we should use runnable.
There's no, okay, so you're saying that the reason you use the implementation interface versus extending the thread was that if you want to extend it, a class, then you will have flexibility to do it.
Yes, that's what.
Like exception handling. Okay. So that's, I understand. So now I understand this concept. Why you use it. Implementation versus
class.
Extension. Extending. So right now, in where we start the conversation was the top. You had open bracket new, and the reason you say you pass in an object of the class that you created. Okay. You say you can do two ways. Either you could do pass the R object you created, or you can pass it new my runnable. Okay, got it.
So now in this scenario, what will happen? That the run method of this runnable will be called. We have passed this thread constructor, a runnable object, and when we start this thread, what code will be executed? The code that is written inside the run method of this my runnable. So this code will be executed. 13 printing of 13 and 14.
Go back. So what happened line 8? Now you have the object, then you pass that one in the thread. Okay, and the thread now you started. Okay, it's calling that object that you pass. Object to make the call. So, okay, got it. So it goes straight to the my runnable.
So okay. So let me move this comment to over here. So now what will happen? like 1 and 2 will be printed, then a new thread is started in line number 10. At the same time of point, main thread will also continue running. These lines are running in concurrent with these two lines. So now if I run this code, what will happen? 1, 2 will be printed, and then two threads will start running simultaneously. Okay, is this output understandable?
Yeah, but what is the difference the previous output and this output now?
There is no difference. What I wanted to show is, like, there are two ways to create threads. I wanted to show both the ways to you.
Okay, the first way you just normally thread, put it, okay, you call it a thread, okay, and then go. Can you scroll down? I want to see the first
approach.
The first approach. So the first you call the my thread, extended thread, and you just print the normal. And this one you use a runnable implementation. And it does the same. Okay, so it's called direct and printed. They both, one is a thread, extended thread, and one is runnable. Okay, one is the interface, one is the class. Okay, got it.
Now let me uncomment this part also. I can uncomment this part also. Now what happens is, we have now three threads. One is main thread, and we have this thread T2 and T1. We have three threads running at the same point of time.
Okay.
We can create as many threads as we want. So if I run this code, you will see three threads. You see main thread, and we have thread 0 and thread 1. There are three threads now, and they are running simultaneously.
Okay, main 0 and 1.
Like, if you want to give a meaningful name, you can do that also. Like this the thread constructor, what it has is, it has a way to provide the name also. So like earlier what we had passed is only R. Now I can name this thread also. What I can name is like let's say second thread. I am giving it a name, second thread. And again this hello again
your connection was
so
that's fine, I can hear you. Go
ahead. There is a way to provide the name also. Over here I have provided the name. The constructor also takes the name. So if you see, there is main thread, there is second thread, and there is thread 0. There are three threads. So like, you can name a thread whatever name you want to give, and when you want to get the name, you use this method, thread.current thread.get name. In line number 9 I am providing the name, and in line number 15 I am getting the names. If you want to set the name, you can set it this way. If you want to get the name, you can get it this way. Okay, so now, hello friends, welcome to live tech study. I am Pranav. This is the recording of one of my sessions that I have taken with one of the students. If you are also looking for similar kind of sessions, you can contact me on livetechstudy@gmail.com. Thank you.